Hello everyone, I am P.R. Ratan Kumar. Today we will discuss about Gauss Law in Electrostatics. Gauss Law in Electrostatics is a very important law in electrostatics. It states that the total flux over a closed surface is equal to 1 by epsilon naught times the charge enclosed within the surface. The surface is called Gaussian surface. So the Gaussian surface encloses a charge Q in a medium air. The flux enclosed by the surface is equal to 1 by epsilon naught times the charge enclosed within the surface. We will divide whole the surface into infinitesimally small surface elements, ds. We will call as ds. So at each surface element, we will calculate the flux within the region by taking the value of electric field and the direction of the electric field, and also the surface value there, surface vector, which direction it is there, then we dot product it, and after getting E bar dot ds bar at that point, now we will apply the same formula to whole the surface by integrating complete surface integral. Then we will find out the total charge enclosed by the surface. Today we will discuss about differential form of Gauss law. So this Gauss law we have already discussed earlier. Gauss law states that the charge enclosed by a Gaussian surface is equal to epsilon naught times the flux over the Gaussian surface. So if there is no charge inside the surface, there is no flux inside over the surface. So you will get a total flux equal to 0. So we have already discussed about Gauss law in differential form, Gauss law in an integral form. Now we will discuss about differential form. I myself Ratan Kumar. Let's look into it. So according to Gauss law, the total normal electric flux phi E over a closed surface is 1 by epsilon naught times the total charge Q enclosed within the surface. So phi E equal to integral E bar dot ds bar. Why we are doing integral is because we are adding all the surface elements. We are taking E bar dot ds bar at each surface element ds. So we will find out the dot product of E bar dot ds bar at each surface element ds. So integral E bar dot ds cos theta equal to so the product of E bar dot ds is integral dot product is eds cos theta, that is equal to 1 by epsilon naught into q. So please note down, and if you observe this diagram, so in this diagram you can see, suppose this is a Gaussian surface, let's recapture, and if we divide it into several parts, and each part we will have a different each part we will have a different direction of ds bar and different direction of E. So these two E and ds product at each element gives the flux at that point. So this gives the flux at this point. So if we integrate everything, then we will get total flux enclosed by it. But according to Gauss law, the total flux. Instead of doing individual thing, Gauss law given one formula. It states that the total flux equal to Q by epsilon naught. So that is a very nice formula by Gauss, the scientist. So if you want to understand better this one, you have to first learn about vector divergence of vectors. Divergence of vectors. Now, suppose as a recap, in this Gaussian surface, this is the theta in the angle between electric field and ds bar. You will get a theta. So here, this at this specific point, it is eds. E bar dot ds bar, and if you multiply you will get cos theta, like ds cos, as you know the scalar product. Yeah, scalar product, you know the scalar product, a bar dot, sorry, a bar dot b bar equal to magnitude of a into magnitude of b into cos theta. Theta is the angle between the two vectors a bar and b bar. Here we have E and ds. So like that way we will find out the flux here. So this is clear, I think. Now, yeah. So the differential form of Gauss law is, the statement is divergence of E bar. That is we represented by using del dot E bar. Divergence of E bar equal to del dot E bar equal to rho by epsilon naught. So this is a differential form of Gauss law. So divergence of E bar. So we have lot of things with vector like curl and divergence. Divergence of a vector gives a scalar quantity. So we have to remember that divergence of vector is scalar quantity. So what we will get is the lines of force, electric force, divergence of E bar is equal to rho by epsilon naught. So rho is the charge density. It is a volume charge density. Rho is a volume charge density. So the rho is volume charge density. We will discuss more about this volume charge density, and epsilon naught is the permittivity of the free space. Permittivity. So like that, del dot E bar equal to rho by epsilon naught. So please note down that formula. So here, after I think everybody has noted down. Now, so like that way, this is one of the important formula. You will get this one in not only in electromagnetism, in several areas of physics. Here there is no time component. There is no time component in it. There is no time component. So the charges are at rest. Here we are taking the charges are at rest. In Maxwell's equations, later you will see the charges are moving charges, where magnetic field also come. So in in Maxwell's equations of electromagnetism, we will see further the modification of this formula later. Now let's recapture about types of charge densities. Charge density. Density means, as you know, that is what you know is a mass by volume. Is a density. Mass by volume is the density. Generally we know the density like this, but mass by volume, it is represented by something. Suppose if we represent D equal to m by v, like that. So mass by volume. So here we are taking charge density, that is number of charges per unit volume or unit surface, or per unit length. If it is a volume, suppose if we have a volumetric body like a sphere, like that, so we will find out the total charge on the sphere by volume of the sphere. Then we will get a volume charge density. It is represented by rho. Suppose the charge is distributed, instead of like this, charge is distributed on a plane. Suppose charge is distributed on a plane, then we will find out the area of it, and we will find the q by a, q by a charge by area, q by a, q by a, it is a charge by area. Charge by we will get charge by area. So like that, charge per unit area, we will get charge per unit area. So if there is a charge per unit area, then we will get like this. So that is represented by surface charge density is represented by sigma. Now if it is a linear charge density, charge per unit length, charge by length. Suppose the charge is distributed in a linear way, like something like this. So suppose the charges are distributed like this, and its length is something like L. Then we have to linear charge density, charge per unit length. So Q by L, it is represented by the lambda, represented by the letter lambda. So like that, here we are considering the three charges, three type of densities. It is volume charge density, and volume charge density, surface charge density, and linear charge density. So like that way, three charges we are getting, three charges. Next, like that way. So here in the previous formula we are taking volume charge density. So volume charge density by epsilon naught. Why volume we consider? Because in Gauss law we have already discussed earlier, the surface integral of the electric field on a Gaussian surface equal to divergence of the field, which we will discuss in the coming chapter, coming slides. Now, so before further discussion, let's see about integrals. There is here you can see rho dv. What rho dv will give? It will give the charge at that point. Suppose there is a volume rho, you know, rho is q by volume charge density, it is q by v. Now I am multiplying with dv, so this cancel and the resultant will be the charge. So the total charge, if we want to in 3 dimension, in 3 dimension volumetric, suppose it is a volumetric object, in 3 dimensions we will take triple integral. It is a triple integral, that means complete volume we will integrate. So rho dv, like that we will get a rho into dv triple integral equal to the charge. So suppose there is charge is distributed on the sphere. So the volume is 4 by 3 pi r cube. Suppose there is a certain charge like something like some 40 coulombs, like that. Suppose there is a 40 coulombs and the volume, it is a radius, as you know, the radius of suppose if it has a radius, 10 radius like r, some radius. So what is the formula? Will modify into q by v. What is the volume of the sphere? 4 by 3 pi r cube into dv. dv, like that way we will get. So but v depends upon the r. So here again we have to convert this formula. You have to more simplify it. So this is the formula 4 by 3 pi r cube. So here the values we have to make it like this. So 4 by 3 pi r cube in q, like that way we will solve this problem integrations. So as a whole there will be a volume charge density rho sorry, and dv, like that way we will have a charge enclosed within a volume equal to volume integral of charge density into dv. Now the types of volume integrals: surface integral, we have integral, surface integral, volume integral. We have volume integral. If we integrate around the volume, we'll have volume integral. If we integrate around the surface, we'll have surface integral. Surface integral we will show using 2 integrals, whereas volume integral we will show using 3 integrals, and normal integral, as you know. And there is if you take around the closed path, then we have a closed integral, which we will represent it by circle. Yeah, like that way. So these are the types of integrals. So before solving further questions, further types in Gauss law, you have to be aware of these type of integrals and charge densities. It will make you the understanding of further derivations easier. So we are discussing basics of what is the formulas coming parallelly. Students should learn all these things thoroughly because mathematics plays a very important role in understanding physics. So if you try to more concentrate on each terms and the reasons why we are using the specific integration, why we are using specific charge density, what is the meaning inside it. These things has to be thoroughly learned. Now, as you know from Gauss law, let's derive differential form of Gauss law. As you know from Gauss law, integral E bar dot ds equal q by epsilon naught. So that is equal to q. Instead of q, we can write rho dv, volume integral of rho dv. Like that way we can write. So from Gauss divergence theorem, so in vector you would have recaptured in Gauss divergence theorem, we know that the any surface, the closed integral, surface integral is equal to divergence of the vector E bar dot dv. Divergence of triple integral. This is converts here. I have to observe that surface integral we are converting into the volume integral. So in the surface integral, so the closed enclosed Gaussian surface, three-dimensional surface, the value of surface integral of complete E bar dot ds bar equal to volume integral of divergence of E bar dot dv. So from Gauss divergence law, we will get this formula. So the surface integral of E bar dot ds bar equal to volume integral of divergence of E bar dot dv. So now on substituting, we know that divergence of E bar dot dv equal to in the previous, as we have seen, E bar dot ds equal to, we got 1 by epsilon naught triple integral into rho dv. So if we substitute that one by in this place, we will substitute this one 1 by epsilon naught triple integral rho dv. So we will get divergence of E bar equal to rho by epsilon naught. Divergence of E bar equal to rho by epsilon naught. So like that way we will have divergence of E bar equal to rho by epsilon naught. That is equal to, we can represent divergence by using this del symbol. It is inverted triangle del. This is called del. Whereas this one is, we will call delta. So del means, as you know in vector calculus, suppose if we get del bar means dou by dou x I bar plus dou by y j bar plus dou by dou z k bar. So this is called like that del dou by dou x of I bar plus dou by dou y of j bar plus dou by dou z of k bar. So like that. Now del dot E bar equal to rho by epsilon. So finally this is the differential form of Gauss law. Divergence of E bar equal to rho by epsilon naught. So finally we have derived this. This is one of the important question for the exams, and the derivation is also very simple. So before, let's recapture fastly. So what we have done, we have to prove the divergence of U bar equal to rho by epsilon naught. For that one, what we have taken is, as you know from Gauss law, integration of U bar dot ds bar equal to Q by epsilon naught. Instead of Q, we have kept triple integral rho dV, that is volume charge density into rho dV. So both sides, if we substitute this one and like this way, and both dV cancel each other, and integrate, if we take out the integral, and finally we will get dV equal to rho by epsilon naught. So finally we got this one. This one is important for formula from the exam point of view. So sometimes they may ask the problems based on divergence of as you know, divergence of E bar equal to rho by epsilon naught. Suppose if you were given any problem E, then we have to find out any of the other parameter we have to find out. Otherwise we have to simplify the problem by using this formula. So these are very important from perspectives of the exam point of view. Sometimes the Gaussian surface can be cube. Or sometimes it may be sphere, like that. There may be problems based on, suppose if you get a problem something like let me give you, there will be problems. You may get the problems like suppose let's see certain problems. Some problem. In this problem, the radius of the sphere, so there is a Gaussian sphere, its radius is 0.2 meters. So its radius is 0.2 meters, and electric field through the surface E is given something like a 250. So they are asking what is the charge enclosed by that one. So here, as we know, EDS equal to integral E dot ds equal to Q by epsilon naught. So here what we have to do is, we know that E dot ds means, as we are taking completely area, we can take here E dot A equal to Q by epsilon naught. So Q we have already given, Q we don't know. So Q equal to epsilon naught into E dot A. A is the area of the sphere. What is the area of the radius is given? It is equal to surface area equal to 4 pi r square. So epsilon naught into 4 pi into r. What is the value of r? It is given that 0.2 meters. So it is given 0.2 meters. So square of 0.2 square. So total charge we will get. Epsilon value is around something like 1 by 4 pi epsilon naught equal to 9 into 10 to the power of 9. 4 pi epsilon naught equal to 9 into 10 to the power of 9. So so this whole equal to 9 into 10 to the power of 9. 9 into 10 to the power of 9 into 0. This one we can write as 2 by 10 whole square. So this 10 square and this one becomes 7 and 2 is 4. So 9 4s are 36. 36 into 10 to the power of 7 is the coulombs charge. So like that way we have to solve the problem. Here we have here we have one mistake we have done. What is that mistake is, here we have forgotten E value. This has to product with the E value. E value it is given 250. So completely this 36 into 10 to the power of 7 into 250. That comes around something like around something like 2.22 into something like that. So like that way we have to solve completely the problem like this way. So finally we will get this value. Yeah. So 1 by 4 pi epsilon naught equal to 9 into 10 to the power of 9. So here we have to take 1 by 4 pi epsilon naught. Like this way we have to solve the problems will be based mainly on the formulas Gauss law, and it's very important for the exam, and we can solve it easily considering what quantity, what is the relation and quantity. We have to see and solve this problem, like something like E dot ds E dot ds equal to q by epsilon naught. If there is a medium, it becomes a q by epsilon. Similarly, here while integrating, if E is not depending on us, we can uniform field, we can take out E outside, and ds depending upon the surface area, it can be, if it is a cube, the surface area will be different. It will be something like surface area means x into y, so x square, 6 surfaces will be there, then E into something like 6 into x square equal to something like that. We will get these things. So yeah, we have discussed about differential form of Gauss law, and I want to thank Commissionerate of Collegiate Education, Telangana, and our principal, Tara Government College, Sangareddy, and thank you everyone.